everyone, my name is Marian Bahamonde, your first reporter in today's topic entitled Climate Change and Ozone Depletion. Our discussion will focus on climate change and ozone depletion only. Let's all understand what is climate change. Climate change is a long-term shift in global or regional climate patterns. Often, climate change refers specifically to the rise in global temperatures from the mid-20th century to present. Also, climate change is sometimes mistaken for weather, but climate is different from weather because it is measured over a long period of time, whereas weather can change from day to day or from year to year. The climate of an area includes seasonal temperature and rainfall average, and wind patterns. Different places have different climates. A desert, for example, is referred to an arid climate because little water falls as snow or rain during the year.
So there are the different types of climates. So the first one is the tropical climates, which are hot and humid. So the second one is the temperature climate. Temperature climate should have warm summers and colder winters. So those are the different types of a climate change. So what is a climate change? Climate change is the long-term alteration of temperature and typical weather pattern in a place. Climate change could refer to a particular location or the planet as a whole. Climate change may cause weather patterns to be less predictable. These unexpected weather patterns can make it difficult to maintain and grow crops in regions that rely on farming because unexpected temperature and rainfall levels can no longer be relied on. So those are a climate change.
In the polar regions, warmer temperatures caused by climate change are making ice sheets and glaciers melt faster each year. This melting adds more water to the oceans, causing sea levels to rise. Then, as a result, coastlines are being damaged by more flooding and erosion. And as the temperature rises, the ocean water is also getting warmer and expanding, which makes the sea levels go up. When combined with the melting ice from glaciers and ice sheets, this causes the sea levels to rise even more. Higher sea levels lead to more flooding along coastlines and cause the land to erode or wear away over time. This damage to the coastlines affects the environment, communities, and infrastructure near the shore. And the main cause of current climate change is human activities, especially the burning of fossil fuels like natural gas, oil, and coal. When these fuels are burned, they release greenhouse gases into the atmosphere. These gases trap heat from the sun, preventing it from escaping back into space. And as a result, the Earth's average temperature rises, which leads to various environmental changes and impacts.
Global warming refers to the significant rise in Earth's average temperature, primarily caused by human activities. While the planet's climate has naturally fluctuated throughout history, the current warming trend is occurring at an unprecedented rate due to the increased concentration of greenhouse gases in the atmosphere. These gases, such as carbon dioxide and methane, trap heat, intensifying the greenhouse effect. The burning of fossil fuels, deforestation, and industrial processes are major contributors to this human-induced warming. This rapid change disrupts ecosystems, leading to consequences such as melting ice caps, rising sea levels, more frequent and intense extreme weather events, and ocean acidification, posing serious threats to the environment and human societies. Let's talk about fracking tower. Fracking, or hydraulic fracturing, is a controversial method of extracting natural gas and oil from deep underground. It involves injecting a high-pressure mixture of water, sand and chemicals into shale rock formations to create cracks and release the trapped hydrocarbons. While fracking has increased domestic energy production, it raises environmental concerns. The burning of natural gas extracted through fracking releases greenhouse gases such as methane, which contribute significantly to global warming and climate change. So here's what you need to know about climate change. So climate change refers to long-term shifts in temperatures and weather patterns across the globe. Evidence shows that global temperatures and sea levels are rising, likely contributing to more frequent and severe storms. These changes are primarily driven by human activities such as the burning of fossil fuels, which release greenhouse gases into the atmosphere. Addressing this urgent challenge requires collective action and a transition towards sustainable practices to mitigate the impacts of climate change and ensure a healthier planet for future generations.
So now let's tackle about the ozone depletion. Imagine Earth has a giant invisible shield called the ozone layer that protects us from the sun's harmful rays. This layer is mostly found in the stratosphere, which is the second layer of Earth's atmosphere. The ozone layer is made up of a special kind of oxygen molecule with 3 atoms. Pollution from things like factories and cars can damage this ozone layer, making it thinner. A thinner ozone layer means less protection from the sun's harmful radiation, which can cause skin cancer, harm plants, and mess up the ecosystem. So, ozone depletion is like a weakening in the Earth's shields, letting in more of the sun's harmful rays. For easy to understand, the air around Earth has a thin layer called the ozone layer, which acts like a shield. This shield protects us from the sun's strongest rays, which can be harmful.
Are exposed to ultraviolet rays in the atmosphere, they break down into substances that includes chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. CFCs breakdown. When CFCs are exposed to ultraviolet or UV rays in the stratosphere, they break down and release chlorine atoms or Ci. Ozone destruction. These chlorine atoms react with ozone or O3 molecules. A chlorine atoms remove one oxygen atoms from the ozone, forming chlorine monoxide or CiO and leaving an oxygen molecule or O2. Cycle continuation. The chlorine atom is freed again in the subsequent reaction and continues to destroy more ozone molecules in a chain reaction. Ozone concentration. The top image shows depiction of ozone depletion over time with significant thinning of the ozone layer over Antarctica, often referred to as the ozone hole. The depletion was caused by ozone depleting substances like or odds like CFCs released into the atmosphere, primarily from industrial activities. In 1989, world leaders signed the Montreal Protocols which ban all CFCs. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries, the Northern Hemisphere. In 1989, the Montreal Protocols banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. The Montreal Protocols in 1989. In response of the growing ozone depletion crisis, world leaders signed the Montreal Protocols in 1989. This international agreement aimed to phase out the production and use of CFCs and other odds. As a result of the protocols, about 90% of the CFCs in the atmosphere, mainly released by industrialized countries, have since been reduced. This led to a decline in chlorine and other ozone depleting chemicals, helping the ozone layer slowly recover. Scientists estimate that chlorine level will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles. Scientists estimate that chlorine levels in the atmosphere will return to normal in about 50 years. This recovery is expected to reduce the size of Antarctic ozone hole, which has been caused by ozone depleting substances. These changes are largely due to global efforts like Montreal Protocol.